Okay, so now that we know how to do conservation of momentum problems, occasionally you might see a conservation of momentum problem in 2 dimensions, okay? All right, and it's really not much more difficult than normal, right? So normal, you'd have like, your 1, 2, whatever's happening, and then, maybe they, I don't know, bounce off different, maybe they bounce off backwards this way, maybe they stick together, blah, 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 okay? All right, so if these 2 things are going to hit head on, right, then they'll probably stay along this same line, all right? But if they sort of glance off of each other, right, like if they're a little bit offset maybe, right, like where, oops, right, when this one comes in, it kind of like glances off of it and it's not a head-on collision, okay, then they might bounce off, in different directions, okay? Or they might bounce off, it could be backwards, they could stick together, any of the same stuff, okay? So really all that you need to know, okay, is you're in the x direction, right? You'd have like m1, v1 initial x plus m2, v2 initial y. No, that's not what I mean. X plus m2 v2 initial x equals m1 v1 final x plus m2 v2 final x. Okay, so you'd have everybody in the x direction, and then in the y direction, you'd have a similar thing, m1 v1 initial y, m2 v2 initial y, m2 v2 final y, plus m2 v2 final y. Oops. What is wrong with me? It's late, you guys. I'm tired. I'm sorry. Okay. All right. So you're going to have basically 1 plus 2 in the x equals 1 plus 2 in the x final. And then 1 plus 2y equals 1 plus 2y in the final. Okay. So as you can see here again, right, you're going to have 2 equations that you might have to solve simultaneously. Okay. And then basically, right, if you say, after, this ball goes like this, and maybe it'll tell you, 2.3 meters per second at a 30-degree angle, okay? Then you're basically just splitting that, just like you would a projectile or anything else, right, into the Vx, which would be V cos 30, and then the Vy, which would be V sine 30, okay? And then you basically just do the momenta separate in the x and the y, just like normal, okay? So I don't want to tell you too much because I want you to kind of play around with it, okay? But the next page, I want you to do the physics aviary simulation, and it gives you all of the values. So I just want you to calculate and confirm that they're equal, okay? You don't actually have to solve for anything on the next slide on the simulation. You just have to prove that it is true, okay? And you just need to be careful, like, especially in the y direction or in the x, whatever, right? You just have to, like, if one goes this way, right, and then the other one kind of goes this way, right? You need to be careful that this is going to have a positive and this is going to have a negative, okay? So just like with the x direction, how you have to be very careful with your positive and negative, you also need to be careful in the y, okay? Oops. If you do the angle right and you plug in like negative 30 degrees, like it'll come out negative in your calculator. But again, I prefer just really to think about what's happening more easily. Okay. All right. So try the next page. And then hopefully I will be there to help you through the rest.